Hello everyone. Today I am very excited to welcome you on this journey of Kubernetes because we will be explaining Kubernetes in under 10 minutes for your reference and for your learning. So without further ado, so here are so many containers showing over here with on the ship, but there's a line also. Google is running 2 billion containers per week. It's been more than the population of whole world in a month. But we will be not discussing these containers. We will be discussing the containers which works on cloud or and on-prem as well. So uh, if we just jot down the agenda, what we will be discussing today, we start with the pre-containerization era, and we will discussing about Kubernetes. We'll learn about the background and the feature, why it is important, and the architecture of Kubernetes. And in the last, some important workloads. So the journey will be very good. So a little bit about myself. My name is Bashir Ahmad Zishan, and I love giving trainings and consultation, be it online or on-site. I love both. I love making complex technical concept easy to grasp. So let me take you to the little backside, and started with normal traditional network where we have servers, and we have different application for each servers. Then somebody told us that why don't you use VM? Then we moved toward the VM, where a server with all operating system and hardware. Then we have a virtual machines, and each virtual machine has its own softwares, its own OS, and own applications are running. This was a good setup, but had some problem. Then some wise guys said us, why don't you move to the container world? Then we have a container world, and containers are absolute prime one to use, because every hardware has an operating system. Then we have a container runtime, and then each container is using the same OS of the host, and definitely uh, the application on this container. But these containers are very fast, very agile, very easy to use, and very compatible with every system. So the containers, before containerization, every application like user database, application, websites, everything is running on different servers, and they are uh, being stored in different locations like your VM, your server, your DR site, and this all were a mess. But with the addition of containerization, then any application can be run on this container, and this container can work on any of the platform, be it's your server, your VM, your cloud setup, your on-prem setup, anywhere. That is a very much ease with the help of container. But there's a problem, let me tell you. When the number of containers grows up, as we have an example recently of Google, when there's 2 billion containers running per week, that is a huge numbers. So the problem comes in, okay, how to manage these containers, how to make them reliable, how to control them. Then comes the giant Kubernetes. Basically, Kubernetes is a production grade container orchestration system. But yes, I know this is a very difficult definition for you. So let me explain in an easiest way for you. It's an open source container management system. That is the one line definition. You should remember this, because the containers, we know about the containers, but how to manage these things, the Kubernetes is the guy, is a software that help us to manage complete life cycle. If I say complete life cycle, it's been starting from their inception to their scaling, their failover, their self-healing. Everything is being controlled or monitored by the Kubernetes, which was open source software. Is initially built as a bog, and then moved to other softwares. But at the end, it was handed over to CNCF. So CNCF is a, you can say, generic body. It's not vendor dependent. So any of the cloud can run Kubernetes very well. But here still, if you have some query, what is the Kubernetes? How do we understand about the Kubernetes? Then I have one example for you. And that would be a very good example, and I hope you would love that example. Let's suppose you must have seen a movie or an opera where a guy, normally with no ears, he keeps on telling people, like, who are playing piano or violin or anything. He has a small stick, and he is basically controlling all of them so they can play accordingly. So this guy is basically working as a Kubernetes, because Kubernetes is managing all your infrastructure. So that is a very good example for your understanding. Basically, container orchestration has many jobs. It's managing the resources. It helps you to scale up and scale down the containers, load balancing, or you can say complete life cycle management. It's called container orchestration system. So as I was saying, it was initial project by Google, then it was handed over to uh, open source software, that is open source community, that is CNCF. Let me show you. Yes, that is the idea. That is the Cloud Native Computing Foundation. So this is the idea behind. But how do you call Kubernetes? Because I know this has been a very much problem. Some people say Kubernetes, some people say Kubernetes. You can easily call it K8s, because from K to S there is 8 alphabets. So it's very common jargon. You can call as K8s. So if we discuss, you don't need to tell you the need and requirement, because Kubernetes is in high demand. It is the most widely adopted container orchestration system, and the less expert people are there. So we need to learn Kubernetes as fast as possible, so we could serve the community, and we learn Kubernetes and will be having a good time in future. So let's come to the some architecture. Basically, there are two major parts in Kubernetes architecture. One is master node, or you can say control node, and the second one is the worker node. That could be more than one as per your size of cluster or maybe your requirement. The master node is the one which controls all the nodes, be it the worker node in your cluster. It's like, you can say it's like a team lead in your team, which controls all your team management, the task assignments, the resources availability, and all that stuff. And the worker node is like a team members, and we perform data, we perform tasks, and we'll give it to our team lead or the manager, so they can distribute and they can share with their high management. So this is the job of master node and the worker node, and each has different parts to work on. If we see a quick diagram to learn how this is work, any request from the user comes in, it comes to the control plane, or you can say the master node, and master node process it according to the need. He takes data from etcd and then control it and schedule it and send it to the worker node. The main part of worker node is kubelet, which takes the input from the master node and perform the activity. For example, I got a request on master node that to deploy 2 pods. So he will give this request to the worker node, and worker node has to implement this thing. So this is the flow which I was just describing you a little while earlier, that a request from the user in form of a YAML file or maybe in form of a command, single line command, that I need a pod. It comes to the API server, which is a main part of the master node, and master node gives to the node or the worker node to implement. So it's the same thing. If your manager gives you a task to your key team lead, and team lead distribute it among all your team members, and then the team members perform their task and give it back to your team lead, and team lead has to serve to their manager. That is the whole life cycle of our company, and same has to be followed in the Kubernetes world. So workloads, what we can deploy, what application we can make on the Kubernetes Kubernetes cluster. It could be a single element like a pod or container, or to a bunch of several servers. Like, for example, if I'm deploying a website, I would need a deployment where we can deploy our application, our web servers, and we have the data in a volumes, and we have a service to interact with. So there are a bunch of workloads available in Kubernetes, but let me quickly describe few of them for you. The smallest one deployable unit is a pod. Pod is nothing but a container in a common life example, but you can say each pod has one container most of the time. You can have more than one container in a single pod, but definitely that would not be a good practice to follow. Most of the time we have one container in one pod, so you can say pod is the smallest atomic unit of Kubernetes world, and that pod can have an application, a web server, or a Linux, or whatever you want to run on this, because a pod or a container is a small computing resource where you can perform any operation. So you can run by an encrypted mode or a declarative mode, both of them. And other example, if I could give you, is all about config map. Config map is also one type of a resource where you store some data. It's nothing but, you can say, a key value pair. For example, username is equal to Bashir, roll number is equal to 35, address is equal to 123xyz, and this all data is stored in a config map, and you can use config map among the pods. So this could work as a storage unit for you. So this is the config map, but normally config map has the generic data. If it is some confidential data, then you should better use secrets, because secret has some security features as well. So I just described you two different type of resources, a pod and a config map. There are a bunch of resources available, uh, and you can explore these as well. If I just give you a quick holistic diagram for the Kubernetes world, normally these are a few resources which we widely use in our Kubernetes world: pod deployment, job, a small task, config map, secrets, daemon services for, and the flow is something like this. So it's a complete, you can say, workload environment normally we have to use. So here I would like to say thank you to connect with me for this quickest journey in the Kubernetes world, although it's a little bit on the lengthy side, but I'm very excited that and very happy to cover all the major aspects you can get in under 10, 20 minutes for the Kubernetes world. Thank you and wish you good luck.